first thing is first. Now we're seeing this again, so now you should have some idea of how important the special triangles are to us. So I'm just going to go through them. You should be able to reproduce them just like me. This is the isosceles one of length 1. That means I can use Pythagoras to get the hypotenuse of root 2. Does anybody remember what the angles are in there? Yeah, 45 degrees and pi over 4. So I'll just split it like this. Okay, the other triangle is the equilateral triangle of length 2. But then I chop it in half, so I only have 1 on either side. I can use Pythagoras then to figure out that 2 squared minus 1 squared is 3, so this side is root 3. In an equilateral triangle, the angles are all 60 degrees, but one of them just got cut in half. So we have 30 degrees here. And of course, that one's 90. So that's how I can reproduce the special triangles. You can memorize it. You might be able to throw it onto your page quicker, but that didn't take very long, and I now have all of the values I need. There is only one other thing that is going to be used for us to figure out exact values. Does anybody remember what that is? One more picture that helps us. Unit circle. So I'll just jog your memory here. If this is the unit circle, here are the points that are not on any triangle. There's no triangle here. Those points are not in a quadrant. But they will help me figure out special angles and exact values. So for example, if I wanted to know what's the cosine of pi, right? Pi is right here. So this angle, that's pi. The cosine is the x-coordinate, so it would be -1. Okay. Unit circle, making the connection that the x-coordinate is cosine and the y-coordinate is sine. That's the last part of the exact value that you have to know. So this stuff here, these 3 pictures, it's vital that you be able to reproduce and use them for the rest of our trig unit. So there's my 3 pictures. Let's use them to go and work backwards now and solve. So if I told you the sine of an angle is 1 over root 2. Okay. This is the way our job works. I'll walk you through it here. I have to figure out what triangle this came from. So if I, maybe just to make it easier to refer to it, or I guess which picture would I find those pieces in? Yeah, the first triangle. Here's 1, here's root 2. So the first triangle is the one that I'm going to refer to. Okay. If I have the sine, that means I'm looking at the opposite over the hypotenuse to be 1 over root 2. So here's 1. The opposite is a 1, and the hypotenuse is a root 2. So what's the angle? The angle I'm using here is pi over 4. Is there another value other than pi over 4? Yeah, 3 pi over 4. Excellent. Here's the picture. This is a positive value, right? So if it's positive, I'm going to be looking for 2 possibilities. One in quadrant 1, one in quadrant 2. So when we talked last day about all students take chemistry, that kind of acronyms, that means the positive ones for sine are in quadrant 1 and 2. Here's what we found, pi over 4. And I know this is also pi over 4, but I can use that to figure out that this angle here is 3 pi over 4. So there's going to be 2 answers in this case. So to get you in the swing of that and to be thinking about how many answers you're looking for, that's the first thing I recommend that we do, is that we draw the picture so you can see what you're looking for. So let's try that here for the next one. So secant of -2, or sorry, secant of x is -2. Which one is secant connected to? Good, it's the cosine. And where will I find a negative cosine? Yeah, over here in quadrants 2 and quadrants 3. So now I know what I'm looking for are those two angles there in quadrants 2 and 3. Right? So I'm going to see if you can work the rest of the way through. Can you figure out which triangle this came from? That'll give you a reference angle. Once you have a reference angle, you should be able to figure out what those two angles are there. So think about it. Which triangle could it be that this came from? And if you remember your Choshakao, then this is Sha. You're looking for hypotenuse and adjacent, right? So we'll come back to this, but I'm going to pause here, let you guys have a chance to think about it. I'm going to zoom in a bit here while you're just to give me some more space to write on, because I'm going to run out of space. Okay, so did anybody figure out picture 1, 2, or 3? Where are the pieces coming from? Yeah, this is going to be, you can think about it like this. This is like -2 over 1. So that's going to be my hypotenuse and my adjacent. So here they are, hypotenuse, adjacent. That's the angle I'm talking about then, 60 degrees. Okay. So I have my reference. Is pi over 3. So I can then put it into my picture here. Pi over 3. Pi over 3. So now we can backtrack to figure out what those angles are. So what's the angle in quadrant 2? This one here. 120 degrees is correct. Let's do this one in radians. Yeah. The whole way would be pi, but we are backing up by pi over 3. What about the quadrant 3 angle down here? What could we call that? Good. So as I mentioned before, I know you're comfortable with degrees. They're going to leave us fairly quickly, and you'll probably never see them again. You'll just you'll have nostalgic memories of elementary school whenever you think of degrees pretty soon. So if I'll be clear about what units I'm expecting, but you should try and work in radians if it's not specified, because that's usually what the unit of choice is going to be for trig equations. All right, so last one. See if you can do it right from the beginning. If tangent of x equals 1, draw a picture. Which quadrants are you looking for? Once you know where the angles are, you have to figure out which triangle did it come from, or did it come from the unit circle. That'll give you a reference angle. Use your reference angle to figure out the angles. Okay? Try to go through that sequence of steps in your head. I'll pause and we'll see how you're doing. All right, so which triangle are we working on here? Yeah, the pi over 4, the 45-degree one. Again, it's not always going to look exactly like the triangle sides, but that's like 1 over 1. So that's my opposite, and that's my adjacent. So here's the triangle. And I've got my, pick a side, opposite, and adjacent. So the angle I'm talking about is still the pi over 4 one. So tangent's positive here and here. my reference angle is pi over 4. So that's pi over 4 in here. That's pi over 4 in here. So one of my answers is going to be the first quadrant angle, which is just as you see it, pi over 4. The other one is going to be all the way around. That's pi plus pi over 4, so 5 pi over 4. Can I just see by show of hands how many people were able to work that through? Oh, genius. Okay, let's move on then. Question? Okay, now that we're sorted, let's go back to the trig equations. So trig equations are going to go a little step further. I'll take you one step at a time through it. It might be rearranged like this. Now, it's not really that scary. You just have to get some practice at it. All I'm going to do with this is try to get cosine all by itself so it looks like the ones that we just did. Right? That was just the style of equation we worked on. Now you should be able to go through and answer the same part of this for me as far as what quadrants is it in, what's the reference angle, what were the original angles. Okay, now this time just pay some attention here to what we're looking at. We're looking at the range from negative pi to pi. So make sure your answers line up to the domain. Okay, so you go for it and then I'll see how we're doing. Okay, if you're still going, just keep working. I am going to try to catch up to you. So I'm first going to start by thinking about the quadrants. And I need a positive cosine. So positive cosine, that happens over here where x is positive, quadrants 1 and 4. So I need to figure out what this reference angle is to help me backtrack this problem. If I'm thinking about cosine 1/2, then I'm going to look at my special triangles. And here's the pieces that I'm looking for. Adjacent and hypotenuse, which is here. So the angle I'm working on is 60 degrees or pi over 3. So that means I can then use that to call this pi over 3 and call this pi over 3. Now, the only thing you got to be careful of, as I mentioned, is this time this is the domain I'm thinking of when I go forwards and backwards. So the answers would be pi over 3 for this point. And then this one, you might be tempted to call that, what are we at there, 5 pi over 3? And that's correct, but it's not the one I'm looking for. I'm looking for the coterminal one, the one that actually ends up in range. So to get there, I'm going backwards because it's from 0 to negative pi. So that's going to be negative pi over 3. So if you had 5 pi over 3, again, you're correct. You're just out of range because this is our range we're working on. So if you got both of those, you're in amazing shape. It usually takes some practice to get both of those. But hopefully you at least got the first one, the pi over 3. All right, so try the second one right from the beginning. Solve the equation, isolate secant x, and go to it. Okay, so this time hopefully you're looking in quadrants 2 and 3. Secant is negative. And if I'm looking for these pieces, it comes from this triangle here. And secant, that's the hypotenuse over the adjacent. So here's my hypotenuse, here's my adjacent, so it's this angle that I'm looking for, which is 30 degrees, or pi over 6. So I can put that in as pi over 6, pi over 6, and when I move over, that angle, again, if we label it, I'll start here, that's 0, pi over 2 and pi. Go the other way, it's negative pi over 2 and negative pi. So this time I'm going to be at 5 pi over 6 here. And when I go the other direction, I'm going to be at negative 5 pi over 6. Did anybody get both? Good. Good stuff. Okay, so let's just see here. I don't know if... do we want to try one more together, or are we getting... Okay, yeah, fair enough. It is something that we should practice. We can do all of them that are there. It's no problem. If you're getting the hang of it, we can move on, so you let me know. Try these. The next one, 5 sine x minus 2 equals negative 7. All right, so I'm going to start catching up to you. If you're not done, then just peek ahead once you see where I'm at. Okay, so before I go any further here, sine's negative, so it's going to be down underneath the x-axis, right? But before I go any further, which picture am I going to be using? Sorry? Picture number 3, yeah, it'll come from the unit circle. If you go like this and you try to make a triangle, you could call that negative 1 over 1, opposite over hypotenuse. There is no triangle with an opposite over hypotenuse like that. You're not going to find it in the triangles. In fact, it's I don't think you can make a triangle like that, right? The hypotenuse has to be longest, and it's not the longest there. So that's how you know that it doesn't fall into a triangle, and we have to go to the unit circle. So we can peek over here at the unit circle, and then we have to ask ourselves, how does sine connect to the unit circle? What is it? How is sine connected to this problem? It's the y coordinate. Which y coordinate are we looking for? Right, so this is what we're looking for here, a y coordinate of negative 1. Okay. So that's the point that I'm referring to here, which would have an angle of... Yeah, so in our example, it would be negative pi over 2. So I'll put that down here. I'm going to have to use the unit circle rather than a triangle. And at this coordinate, this says the sine of x is negative 1. So what angle is it? In our range, that's negative pi over 2. It's only the one answer. Okay, so do we want to try one more? Yes. All right. 2 root 3 tan x plus 1 equals 3. Give that one a try and see if you can solve it from start to finish. Can I just see show of hands? Is anybody not getting, feels like maybe I need to come help you out while you solve this? Because I'll come there while we do this one. Okay. Okay, so I've got a solution there. You can double check. I have been known to make a careless mistake. I just butchered the lesson last day, if you remember. So hopefully, can somebody confirm that this is what they had as well? Yeah? Okay. Uh-oh. Oh, it's not root 3 is what you're saying. Yeah, it's not root 3. So you are paying attention. Okay, so that one is opposite over adjacent. Good stuff. Pi over 6. So I'll just make a couple of adjustments here. Oops, I should have that too. There. It's like it never happened, except for the fact that it was recorded. All right, is that better? Okay, that I can agree with. Okay, I'll zoom out here for a sec. All right, so we've already solved this equation here, but there's more than just the values we talked about. So here's the one that we were dealing with. And we came up with 2 answers. Can anyone give me another answer that we could use? For example, one of them was pi over 3. Another one was negative pi over 3. Are there any other solutions if we just ignored that domain? 4 pi over 3? 2 pi over 3? How would you find? There are lots of other answers. Can anybody think of a way to plus 2 pi? Yeah, what do we call that? Oh, well, you're looking at general. But what do we call it when you added 2 pi? What happened to the angle? It's coterminal. So basically, that's what we're saying here is we could also call this, if I add 2 pi, I'd be at 7 pi over 3. If I add 2 pi, that would be 13 pi over 3. 19 pi over 3. Right? Same thing here. If I added 2 pi, I'd be at 5 pi over 3. And I'd be at 11 pi over 3. Now, whoops, it would make quite the detention if you had to list all the angles, because you'd be here forever. But we can do it in a little bit more mathematical way to cut that process down. The way we write a general solution is we say, here's the angle that's, the primary angle, or the principal angle as we've been calling it. And what you're going to do is just add 2 pi n, where n is an integer. So same thing applies to negative pi over 3 plus 2 pi n, where n is an integer. All right, so this time that's what I'd like you to do, is I'd like you to solve it and then give me a general solution. So this time we're going to mess around with that range again. We're going to go from negative 2 pi to 0. We'll play around with that range until we get the hang of it, but usually it's going to be something like 0 to 2 pi, negative pi to pi. It won't be too crazy, but you do need to get some practice at that. So try those and then give the general solution this time. Okay, so hopefully you're getting the hang of this. You can get to this point where you have all your references labeled in your picture. Now we got to go backwards because we're dealing with a negative range. So this is my first angle, which is going to be negative 2 pi over 3. And then the next one is when I go all the way around to here. This is negative 2 pi, and I've backed up by pi over 3. So this should be negative 5 pi over 3. So two of my solutions in that range look like this. And if I wanted to give the general solution then, could look like that. Now, one thing you're going to notice about the tangent, which it's actually, you can see it probably better in the picture. I'm going to get rid of these red arrows for a second. If you look at that picture, they actually spin around 180 this time. I'll show you what happens. See, there's 180, and then I get to the next angle, and then the next angle, the next angle. They're like on a straight line, right? So if I was to show you what these values look like, that's going to be negative 2 pi over 3. Then the next one's going to be 4 pi over 3. Then 10 pi over 3. And keep going. Whereas this one's going to be like this. So if I follow this along, it's going to be add pi to get there. Then the next one is add pi, then add pi, add pi, add pi. I can actually get all of the answers in one if I was to write it like this. Because then if I move by pi, each time I'll hit the same angle. So you can combine those two in the case of tangent and cotangent rather than working with two separate ones. Question, yeah?
Are we allowed to subtract 2 pi also?
Yeah, because n is an integer, it'll be positives and negatives, but just know that generally it would say plus 2 pi n, because then the value of n will be positive and negative, so you still get both. If you would subtract 2 pi n, it's fine, but the convention is usually plus 2 pi n. You'll still get the negatives, right, since they're integer numbers. Okay, and then the most annoying thing in Math 12. Okay. So we land on those angles every pi. So when you check over your work, you might also notice that, oh, the answer in the back's different from me. It's maybe not that it's different, it's just that they've combined those answers to make one, like we just did here. Yeah. That is the preference, yes. That is the simplest form. Like when you're asked in simplest form, that is the simplest form. One answer does both the other ones. Okay? And again, the way you recognize it is looking at your angles. They make a straight line, so it's going to be every 180 that they start to repeat. It doesn't work, for example, in the next one, because if I just quickly show you, if cosecant is undefined, oops. What does that mean? Do you remember, like when your calculator says, oh, yeah, that means we've probably divided by 0. Okay? And do you guys remember, what's cosecant connected to? Yeah. And how are they related? Reciprocal. So if the sine theta is 0, when you flip it, the cosecant's undefined. So if you make the connection back to them, I'm going to be looking on the unit circle for where the sine of theta is undefined. So let's draw that picture in here. Sine of theta is 0. Can anybody tell me? Yeah, and there's another one where sine of theta is 0. Yeah, over here. So for our angles, those are the ones we're working with. So I've got actually 0 and negative pi for my answers. And again, if you look, it's going to keep repeating every 180. So this one here, you can write it like this. Or we can simplify it and just call it, sorry. Okay. So where it won't work is if your angles were like, say, these two lines in green. If it was a quadrant 1 and 2 angle like that, it won't work as plus 180 because you can't get from the one green angle to the next with 180 degrees, right? You can only do it with a full loop. So if it's not a straight line, you're not going to be able to make that simplification. Now, this is actually easier than what we've been doing, and that's what about if we don't have values from the special triangles? And that just means you have to use a calculator to do it. So do you guys remember how to go backwards? How do you find, if sine of theta is 0.75, how do you find the angle? Yeah, it's the inverse. So in your calculator, whoops, and let's work on radians here. So remember to check that you're in the right mode for this. Yeah, and I'm in radians. And I'm going to go inverse sine of 0.75. So that's going to be the angle I was looking for. We'll call it 0.848. Oops. 0.848. And if we wanted to give the set of answers, what my calculator has given me is a reference, right? So this is going to be positive. It's the same process. I'm looking in here, and my reference is 0.848. So this first angle I'm looking for here, that's just as I see it. How am I going to get this second angle over here? Yeah, it's pi since we're working in radians. 180 is the correct thought. It's just that we're doing this in radian mode, so we should be in radians in our calculator. So, or pi minus that 0.848 to get the second angle. Okay, so pi minus, if you don't know, this is a handy one. You go second function and answer. That can use the answer that you've already stored. So 2.294. Okay, so those would be the two answers if I did it with the calculator. So the process is identical. It's just you don't need to refer to the special triangles to get the reference angle. You can use your calculator to get a reference angle. So you guys try secant of theta equals 7, and you won't be able to use a special triangle there because there's no triangle with side 7. Okay, so let's go through the same process. It's positive, so that means I'm going to be over here. These are where my angle's located. I need to use the calculator to help me figure out a reference angle for this. Okay, so here's, I don't have an inverse secant. How am I going to do this? So the way I would think of this then is the same answer would say cosine is 1 over 7. So that's what I can put into my calculator is the inverse cosine of 1 over 7. Okay, there's no inverse secant, but you can switch between secant and cosecant. So I get 427 for my reference angle here. this is... Okay, so the first angle is easy. It's as I see it there, 1.427. The next angle, how am I going to calculate the next one? Yeah. So this is 2 pi over here, so I'm going to take it away. I guess I'm pushing too hard today. 427 there. Okay, so 2 pi minus 1.427. Okay, so that's 4.86, we'll call it, or 586. Okay, so those are my 2 answers using the calculator instead of special triangles. All right, so hopefully I haven't completely blown your minds, because that's some heavy stuff. Before we take your break to go and practice some of this, there's some notation. It's real simple, so it's not too bad, but this is a notation we're going to start using. This is the notation that's most common for calculus as well, so it's kind of handy that we get to talk about it in Math 12. This notation, I don't know why they didn't start with this. It makes more sense to me than inequalities do. But these round brackets we're going to use for open interval. That's usually the way it's described, meaning exclusive or not including. And these square brackets, they're usually used for a closed interval, and it means inclusive. So how do you interpret these 2 intervals I've just given you? So 3, 7, this is the interval from 3 to 7, not including 3, but including 7. So when you run into a square bracket, it means this is part of my answer. If you have a round bracket, it means it is not included in my answer. So the second interval would be from 2 to 5. Can someone translate for me how those square and round bracket are going to turn out? Including 2, not 5. So we could use both square brackets, both round brackets. You know, we can mix and match them. And just to show you how it connects with what you already know with inequalities, if I call this number 1, usually you'd write this inequality like this, right? And you'd say include the 7. So you put an equals there. Right? The other one, if you're going from 2 to 5, you include the 2. Okay. So between those, you're going to need to get used to both notations. And again, as we hit calculus, you guys will see that the interval notation is most common. All right, well, that was a marathon. Way to hang in there.